I wanted to create a quick video to talk about recursion and show something that is visual of what recursion actually does, and something also that has to do with a practical application of recursion in a linked list project. So if you are curious about this project, I have it posted here. Notice the capital Q, lowercase od5qeb. So let me take a look at this. All right, so let me do a quick walkthrough of the code to give you kind of the general idea. I've got the struct where I've got a pointer to the next thing in it and an integer a, which is a value that it's holding on to. I have 5 different methods here. A create list, which is recursive, but I'm not going to go over that generally. A print command, which uses iteration. A print command, which uses recursion forwards, and a print command, which prints the list backwards, also using recursion. And finally, I'm going to try doing something where we insert a value into the list using recursion. The basic commands are going to be, I'm going to create this head of the list and set it equal to create list, which is going to create a list. I'm going to print it backwards, forwards, iteration, insert 3 values in it, print using iteration at the end. So to begin with, let's take a look at create list. So it jumps down here. I'm going to create a new node and basically create values 0 through 2. So it creates a value 0, an object on the array. So this is the first call, and in is 0. It sets the next node, creates an object for it, creates the next node, an object for it. And then, as it's returning, it sets the next node of the array to whatever was created. So this guy's next is going to set equal to whatever array spot was created here. So by array, I mean an object of that type. So notice then it basically is linking them back together as I return. All right, so print backwards. This is a recursive call where we do the recursion first. So we do print backwards here. And then we print them out on the way back from the recursion. This is called doing an action on the unrolling of the recursion. So we're basically going to walk through all of these different things, get to the end, and then as we're returning, we're doing some action, in our case, printing. So here's my base case. If the next thing is not equal to null, then we do a recursive step where we set it equal to the next one. Print backwards gets called the first time. It's equal to my head pointer. It gets called again, where it's saying that n is the next thing from this call. It's now pointing to this object. Then the next thing, it's pointing to this object. And then it prints it out. So it prints out 2, it returns, the print call gets called from this command, it prints out 1, prints out 0. So that's a way to print all of the things in the linked list backwards using recursion, where you actually just do, after you've gone through the recursion, you do whatever your action is, in our case, printing. So I just put a return for the next thing so you can tell the difference between the two outputs, and then now we're going to go forwards. We're going to print it out first, and then we're going to do the recursive step. So starting off, we're going to print this node, prints out 0, and now we do the recursive step. So it calls print forwards again, prints out this node right there, calls the recursive step. The next node is null, so that's the end of this, and it's going to fall off the end of the method, or function in this case. Return, 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 and away we go. Now you can do printing the same exact way using iteration. So if I go forward, this is a method that uses iteration to do the exact same thing as our forwards recursion did. So the difference is basically I have this extra pointer that I have to keep in memory, which is acting like the stack. So it's doing the same sort of thing the stack would have done. So current's now that one. While current's not equal to null, I'm going to walk through it, and I'm printing it out before I do this thing where I take the next step. So it prints out the 0, current gets adjusted. This gets printed out, and then current is adjusted. This gets printed out, current becomes the next thing, and now it's finally null. It leaves the while loop and ends your iteration. All right, here's the most complicated one. So I'm going to try doing something where I insert the value 4 into this list, then 3, and then -1. And the idea is that it should be sorted in order. So if I print it out, it should be 0, 1, 2, after the 4 is 0, 1, 2, 4, and so on. Now the insert function is a little tricky. I'm passing my head value in here by reference, so a pointer by reference, which means I'm passing basically the actual head pointer into the program. And the reason why is that I need to be able to actually alter this original head pointer from main from insert. Otherwise, if I just, so like P and C here, which is short for previous and current, these are actually going to be copies of the value of pointer. So P is going to point to the same thing, but if I alter P itself, it's actually not going to alter the original value. Same with C. So I have a couple of special cases if I'm actually altering the head pointer itself, and then I go through basically my recursive step down here. So let's take a look at how this works. So if I'm inserting into 4, it should print it at the end of the list here. So I walk in here, head is pointing here. This is the previous and current pointer on the first run through. Head is not null. The value that I'm passing in for is not less than 0. And C is not null. Is the value of 4 less than the value that C is pointing to? Well, 4 is not less than 0. So we jump into this recursive step. Head is passed along again. C is your current, and so current is going to be the previous in the next call. And current's next is going to become current on the next call. So if I take a step, so head is here, previous is actually where it was before, and current is the next thing. We're going to walk through these calls again. The 2 head ones are not going to have any effect yet. C is not null. It's pointing to this node. 1 is not less than 4. And so we do the recursive call again. We're getting pretty far down here. Neither one of the H calls are going to be affected again. C is still not null. 4 is still not less than 2. We do one more recursive call. So now, if we look at C, C is actually null. So we get past the 2 head checks. C is null. So now what we need to do is take the previous pointer, which is this node, that's what P is pointing to, create a new node. So the next thing is now this new one. We're going to assign its value in. And the one after this needs to be set to null. So I'm explicitly saying this next pointer needs to be null. We're finally done. We inserted something in. And so it's going to fall off the end of all of our recursive calls. Next, 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 next. And we're back to our main node. OK, here's a tricky one. What about 3? 3 needs to be between 2 and 4. The head pointer ones are not going to have any effect. 3 is greater than 0, and so it's going to skip past those each time. C is not null. It's not less than, so we do recursion. It's going to keep skipping along until we get down to the 2 and 4 being 2 being previous, 4 being current. Neither one of the head pointers. All right, here we go. This is where the interesting stuff should happen. So the value of 3 is smaller than 4. We skip past the 2 head pointers. C is not null. However, this value now is important. The value that we have coming in, 3, is less than current's value, which is 4. So we go inside of here, create our new node, give it its value of 3, and now we need to repair the links. This guy needs to point down here, and he needs to point back to here. Previous is next, now points to this one. And this new object's next needs to point back to this guy. So new node's next is now C. So now as we unroll, you'll start to see the structure of the linked list. So it goes here to here to here to here, and then back. And then this is null. Inserting only took 2 pointer changes, which is kind of interesting. we didn't have to move all the objects around. It's just using the references to keep things in order. How about -1? -1 is less than this, which means we need to alter the actual original head pointer. So it's not null, but it is less here. So now what we need to do is basically hold on to a temporary pointer to this node. We need to actually alter what head is pointing to. So head is now pointing way down here to this new object on the heap. It has the value -1, which we insert in, and we repair the pointer where this, which the head pointer is pointing to, now points back to the original beginning of the list. How about that for a lot of arrows? So if we actually follow this, the head pointer, the original one from main, points down here, which points up here, to here, to here, to here, to here, and then it's null and it's done. So that's a practical application of using recursion to actually insert something into a linked list. You have to often use this trick with the previous and next in order to repair pointers if you aren't keeping track of that. A doubly linked list would help to solve this, but you still need to repair pointers in the process. And then if you have a head node that you need to alter, that's where you would do this original value. I could have moved these two head pointer calls where we do just a quick check on those two before I actually make my recursive call, but at some point you're going to need to deal with that special case. And then just to prove that, yes, indeed, it does print out in order, I'm going to run the print iteration, which should print from -1 through 4. So -1, 0, 1, 2, 3, 4, current's null, and it ends your iteration. Hopefully that makes it a little bit clearer what's going on with recursion, as well as showing you some practical uses of recursion in a linked list project.